Right. As she said, my name is Jorg Brown. I did most of the design work for something called StrCat, which is part of absl. And it's kind of interesting because it provides a little tour of C++ inefficiencies and some interesting techniques with variable templates. So what started all this about more than 10 years ago was there was a lot of this at Google where people would construct a string using the plus operator. And the problem with that is that there are a crazy amount of temporaries that are constructed there. 10 years ago, it would construct the string for username, append misses to the front, it would create a new temporary. Then it would take the temporary add lives in, make another temporary, then would take that temporary, concatenate it with city, create a final temporary, then that final temporary would be a sign operated into the string, and then all the temporaries would be destructed. It took not only a lot of time, but it generated a ton of code. So my first reaction was, well, why don't I just make a simple routine that just accepts a bunch of stood strings, and we do it that. The problem with that is you still need to create temporary strings for the string misses and the string lives in. But it's still much faster, it still generates much less code. You can do better now that we have string view, or 10 years ago we had this thing called string piece internally. Because now the literal strings don't need to create temporary string objects. They can just create pointer length pairs. So that's already quite a lot faster. Having done that, then I thought, well, wait a minute, if string view is doing this thing where it automatically is converting string literals into pointer length pairs, what if I could also do that for integers and floating point numbers? So created yet another class called AlphaDoom. It's simple, it's basically just a string view, but also a small pad where you can store the digits of a number. And as you can see there's two constructors. All they do is call some shared library code to take the integer or floating point number, stuff it into digits. There's one little extra trick. I couldn't just create a string view constructor because then if you try to pass a literal string, C++ would have to do two implicit conversions. First to string view and then to AlphaDoom. So I have to actually spell out the individual things that are string-like things. So having that, then we just define StrCat, multiple varieties, taking various number of arguments. Their implementation is dirt simple. You just do one initial allocation that's exactly the final size, mem copy the results in. And the great thing is it turned out to be really, really fast. Not only does it not have to allocate a wrong size string, but unlike something like snprintf, we don't have to go through every single character and figure out what the format specifier is and then traverse C-type var args anymore. So this is already 3 times faster, and that's including the overhead of actually allocating a string. Little extra thing though, people quickly ran into the argument limits. The initial one, there was a limit of 9 arguments, then that was expanded to 26, and people still complained. So thankfully with C++11, we have this thing called initializer lists, and we can use them here. So now we can define StrCat. We'll take the first 2 as AlphaDooms, and then the third one will just be an unlimited number of arguments, each one of which will convert into an AlphaDoom, which then we'll grab the string view from and pass that to cat pieces. One subtle thing here, you'll notice that rather than just construct an AlphaDoom, I do a static cast to a const AlphaDoom reference. The reason for that is if somebody else wants to have an interface like this, they might take const AlphaDoom as one of their parameters, and they want to pass that reference to me. And if I construct an AlphaDoom, then I have to copy the AlphaDoom data, whereas if I do a static cast const AlphaDoom reference, then there's no overhead for that. No copy. And then final slide, just, by the way, this is how cat pieces work. Again, we just loop over the initializer list, first grabbing the initial size, allocate the string, then mem copy the data, and the result. And that's why it's fast. This, of course, to be in a lightning talk, it's a much abbreviated portion of the code, but the actual real code is right there. Thank you very much.